Hello everyone and welcome into yet another live stream. Yeah, things are a bit different because one of my drives is just straight up disconnected. Just straight up, not connected anymore. My PC, actually, my PSU kind of broke. Well, the cable, I'm assuming is the cable. I ordered new ones, should be coming in soon. Play some music. What are we doing today? Well, I am so glad you asked. Give me a second, let me just pick something real quick. There we go. Alright. I am so glad you asked, Drone. Well, yeah. Oh, damn it, I didn't bring that. But shucks. Okay, be right back. Okay, don't worry, don't mind me. Just, I'll be right there. Right there, okay? Don't even worry. I'm not going anywhere. It's still hear me. Shucks. This. And what else? Flat sticks. I'm still streaming. Don't mind. I'll be right there, okay? Just a second. I think that's it. It is. Alright. Well, I'm not really back because I was always here. I've never left. Hi there, everyone. How are your days going? Just making his voice quiet that triggers the thing. Yeah, it's a forced perspective, except for sound. Is this was in the chat? Oh, yeah, my PSU broke. I'm assuming it's the cable because the PSU seems to be working fine. So I'm actually hoping it's the cable. I ordered a new cable. If it's not the cable, then oh no, because first of all, I wasted $20 on buying a new cable, and second of all, I'll have to spend like 300 more to buy a new PSU or use my backup one. Yeah, I'm the kind of person that has a backup PSU. Anyhow, today we'll be doing something fun. How's Susie? Susie's fine. Doing well. Listen, I don't do preparations off stream. I do them on stream because if it isn't the cable, if it isn't a cable, I didn't do a fucky wacky. I am a fucky wacky in a pretty fucky wacky spot because oh no, I don't have the money for a new PSU. I guess I could use the old one. It's actually a funny story. Let me show it. You know what? Graphically, I wanna showcase this graphically. Just this spot I'm in, okay? So, ooh, that's bright. So, my old PSU, well, not old one. Right now I'm using the old one. This actually gets pretty confusing. The PSU I've been using yesterday had 1200 watts, and the PSU I'm using right now has 600. That's quite a drop. Quite a drop in the power. Worst case now is not being the PSU nor the cable. No, it certainly is PSU or the cable because my old PSU is working. It has to be either one. I mean, right now I'm streaming from my main PC, right? So it's clearly working with the right PSU. So the problem, I've isolated the problems as such. I've isolated the problem to the like this with the PSU and the motherboard. Let's call it PSU 0, so the one. This is not working, so red. Okay. Then PSU 1, so the one I'm using right now, the 600 watt now. 600 watt and 1200 watt. This one is working. The PSU 0 appears to be working. I'm gonna give it like half a check mark because it's kind of seems to be working. I've been I've been just bugging with the multimeter and it seems to be working. And since because of this, it seems like a motherboard is working. Because of this, the PSU seems to be working, which means it should be the cable. It really should be the cable. If it's not the cable, then oh no. Drives make it like Windows. Worst case scenario is not in the cable. Next stream is just going to be him doing the dishes at this rate. I actually thought about streaming me fixing my PC, but I realized it wouldn't be that interesting on the stream because I wasn't really fixing anything. I was just checking stuff on multimeter. Right now, my computer is wide open. I am using the computer with an open case. Right now, it's just sitting on the floor, case open, and a PSU plugged in like externally. It's a very comical sight. Anyhow, I have something fun for us in store today. You all ready? Can I get like a drum roll in chat? Drum roll, please. Someone like a hype train. Drums, all right, Sid. Whoa, insane! Oh wait, did it crash already? I think it crashed. Fudge. Ah, the camera crashed already. Okay, so there we go. Whoa, insane! it's very cheap, so it might break every now and then. Oh fudge! Ouch, that hurts. Okay, give me a second. I might need a second, right? Right here's my mixer, by the way. No, I couldn't find anything better. Right, yeah, my voice will be a bit different now. I have this thing where I basically what is the cable coming drone to board so solutions. Is he making drone again? Yes, I am. I am making a drone. This was not the motherboard of the drone. This will be different. And I was kind of hoping we could wait for Tefta with this. Because I actually have also some other stuff. Other file stuff. Hi, the Q-End. Hi, how you doing? Damn it. Do I have a knife lying around somewhere? Do I have a knife? I have a whole drawer of knives. Of course I do. Is he Russian? No, I'm not, but I do get... I can see why you think that. Ah, shucks, damn it. Wasp. Oh boy, I'm not a computer or electronics guy. Don't worry, neither am I. Ah. Is Theta coming? Yeah, Theta is coming soon. To theaters near you. It's just that I started live stream before Theta could join in because I wanted to get a bit ahead and I already gotten way further ahead than I should have, so... For me, it looks like this. Hide numbers, the better it is, probably. Yes. Honestly, yeah. I mean, that's kind of what we're going for. If number gets high enough, we hopefully... Well, that's the issue. Right now, we'll need the numbers to be alternating back and forth in order to go high. If it was just number goes high, that would be a pretty simple thing to solve. Almost there, almost ready, okay? Yo, just... Why is this packaging so tight? Boom! The camera crashed again. No, it didn't. Why is it crashing every couple of seconds? There we go. It's a freaking brushless motor Which, oh wow, it feels weird. Also, this camera's way too far. Oh boy, it feels weird. Really. It has freaking coils and no brushes because it's a brushless motor. So you know, if you want a brush-through motor, this is not your guy. There we go. Next you're making quantum camera. Quantum camera? I don't think quantum camera is a thing. I mean, cameras detect light. That's important. I mean, all cameras quantum. Making something for a few streams ago, some ESC or something. Yes, today that's what we'll try to do today. An ESC. Or an electronic control system. Or electronic system of controls. Or electronic something. C. Something. That's what we'll make. So, you all ready? Because I'm not. Alright, we'll be able to see my lovely keyboard. And apparently me? Is that me? That is me. I think at least. I don't know, the orientation on this camera makes absolutely no sense. Geometrically, it's bonkers.
Bonkers.
Delta! Oh my goodness, hi there. Hi, I have a thing set up. Hi, how you doing?
Awesome.
I'm
Good.
just
How are you doing?
pretty well, let me wave you. Hi there. I don't know how to look actually. Hi, I have an idea. Okay?
Oh,
I
that's
know,
awesome. You got one of those boards that manages the power rails.
Yeah,
That's
because
awesome.
because here's the thing. Today, I actually give me just a second because this. Ouch hurts. I've changed up a bit my mask setup, so that it right now it sticks better, but it also hurts to wear. Anyhow, I think
This view is really good for the board.
I
It's
know,
a really good view.
I know. I'm really happy with this camera. The downside is it crashes every 5 minutes. To be fair, it was really cheap. I feel like just the shipping cost alone should be higher than the cost of the entire camera. So that's a bit shady, but you know. Anyhow, I have an idea. Let me give you a stream. Can I stream to you OBS or something? That would be more
Yes.
convenient. Now I wouldn't have to switch scenes. Hold on, let me just. Alright, I'm gonna give you a stream of my screen and. Well, actually, wait, what's the delay on YouTube? Because maybe on YouTube this time would be easier. I could switch between.
It is not played at all. Okay.
Oh, well then, you know what? I'm actually gonna do it on YouTube.
Well, snap your fingers so I can hear it in the mic, in the camera.
Hi, the make it in chat. Hi, the Ali. Would you say? I'm sorry, I was readjusting. This mask is so painful. It's so.
Can you snap your fingers in view of the camera? Oh, okay. It's I meant on YouTube, but gotcha. Okay, the delay is 3 seconds.
3 seconds. Okay, that's could be worse.
Yeah, it's really not bad. How's it going, Allie?
Right, so. Wow, this is so freaking painful. Why am I doing this? Ow. Ouch. Okay, so I have an idea for how the PSU could work. I mean the ESC. Sorry, the
Power supply unit.
The power supply unit is on my mind because it freaking broke yesterday.
I'm good, Allie. How are you, Allie?
Yeah, I was about to say. Okay, yeah. I mean, I'm just gonna do it. Okay, so here's the thing. Since we have our lovely beloved RP 2040, right? Since it is already there, and since we will use it to control the brushless motor, this lovely artist interpretation of a brushless motor, then what we basically need the ESC to do is we just need it to have 2 inputs because that's the minimum number possible. 2 inputs per phase. Okay, this is not an ESC, this is a single phase ESC. So this will be just connected to 1 input, and we need 1 input which will basically control whenever the voltage flows or if it doesn't, right? So voltage or no voltage, or 0, no voltage, and the second one, which will just determine if it's a plus or a minus. And
Yes.
what I was thinking is that, wait, couldn't I do it with just transistors and that's it?
So the only thing I don't know is that what happens when you flip the voltage. You're going to need some diodes there to catch it from flowing backwards.
Yeah, but here's the thing, I'm pretty certain I could flip the voltage around with only transistors. I don't think I need any special circuit for that.
Well,
I mean, I do need a
you will
special
need
circuit. Just,
diodes.
yeah.
You will need diodes, yeah.
Wait.
True. So you're just gonna try to like Okay.
Yeah, so set up a circuit which will allow me to flip the voltage around. And actually, I suppose I should do it in Checkup first.
Yeah. Because I think I've been looking at circuits, and that's what they've been doing. Because usually, what you do is you have one bit interface, right, or just serial interface. So either it's a 1 or a 0, and that just tells you if the voltage is positive or negative. And then you have the pulse width modulated signal, which it mimics the analog output just by the duration of the pulse width modulation. So that way it averages the sinusoidal wave output. So with the bit operation, either high or low, plus the PWM, that's how they kind of switch it back and forth.
That's a lot of long words. My
Sorry,
vocabulary is limited to 2 syllables, alright? You just... If you're going over, that's the danger territory for me. I'm a simple man, alright? I understand transistors.
So how are you... Yeah, so you're still going to just use the PWM, though, to mimic the waveform, the sine wave output, right?
Yeah, but do we need a sine wave or do we just need 3 phases? Because I don't think sine wave is required.
Yeah. So you can either use trapezoidal, right?
Yeah, that's the one I'm going for.
Okay, yeah, that's the simplest one. Yeah.
I
Then
know.
you would just have a ramp up time. Then it would be max voltage, then ramp down time. Yeah. Yeah, that works too. That's the simplest type of ESC that you can make is a trapezoid one.
Simplest type is a real. That's a sell for me, honestly. It really sells the idea. The simplest kind. I ain't doing nothing fancy. So now all I need to do is figure out how to switch the voltage from positive to negative. Let me actually first find out how.
Now that I don't know how to do safely.
I mean, I have one idea, but it's a very dumb one, and it will require a lot of transistors. So I'd rather see if there's like a smart way to do it with. I don't know, transistors controlling only where the ground is or something. Hold on, from positive, negative. Because I have one idea, but it's pretty silly. Is it like a... Huh.
Because I really think that the sinusoidal one is actually not as difficult as it sounds. You just literally modulate the PWM with... it's like a single line in code.
Wait, PWM.
Yeah, PWM is pulse width modulation.
Oh, so it's just... Oh.
So what they do is instead of having, let's say, 0.1 volts, they'll just cycle it on and off really fast for like a millisecond. And then it averages out to 0.1 volts. And then when you want to hit 3 volts, you cycle it on and off maybe 15 times. You know, and so the average on and off voltage would end up being the 0.4 volts or whatever.
Hungry F1 just said, oh god, I thought the sine, cosine, tangent was only for school.
No, it is not.
No, unfortunately, you can never escape the waves. The waves will always follow. So the reason why this is such a big selling point for me, honestly, is the fact that this would be an unbelievably easy to make and unbelievably cheap to make circuit. And then you will, I won't have to worry about matching parts with the PCB maker. I won't have to worry about matching parts with capacitors or something. It would just be transistors, and transistors are way simpler when it comes to matching. You just mostly have to only care about the maximum voltage stuff like this. So
Yeah, and especially I guess for the trapezoid one, I'm not sure how they do the ramp up, but I didn't study that circuit that well. But that works. Technically, you can get that to work, and it should be able to move the motor.
oh, this is exactly what I've been looking for. Hold on. Is this exactly what I've been looking for? It might be. Out negative. Wait. Oh, this is okay. This is kind of what I meant. So this is like a smart way to do the solve circuit. We have only at this point you would have only two. It's a smart way to do a circuit like this. It's just that because it depends on some actual electronics. Why is there a quote appearing? No, I have to bring back. Don't throw any wild parties without me. I'm using make it a procrastinate smart procrastination. I mean, you can learn actually on this live stream. You can learn the fair share. You know, you can learn a fair bit on TFT live streams. I gotta say. Negative voltage circuit. We don't have to understand what negative voltage is. When is negative voltage used? Right now, producing negative voltage. Yes. One of the ways to produce negative voltage is by taking advantage of the effect of capacitive coupling in capacitors. Okay, capacitive coupling is the effect in which there is transfer of energy within distant electrical network via displacement current. Oh, gee whiz, this is gonna be simple stuff. This effect, capacitor tends to keep the voltage across its terminal constant. So when the capacitor plates are initially 0 volts and the one plate is pulled to 8 volts, the other plate tries to also rise to 8 volts. Similarly, when the plate is also brought back to 0 volts, there is a negative charge on the other capacitor plate of negative 8 volts. With this effect in mind, we can now make a negative voltage supply very easily with the help of a couple of switches.
Did you see that link I sent on the 18th, where it interjected you like right in the middle of a video?
The Tefta hat one.
The brushless power. Why brushless controllers are awesome for robotics.
You have to be a bit more specific than that.
Okay, let me. The only reason is I only want. It's only like 15 seconds. I was wondering if you could watch it, because you do understand how the PWM is used, because it's actually really easy.
What is brushless power? It's a brushless motor. It's the basic idea is you have motor, in which actually basic idea is rather simple. If you ignore all of the electronics, you just have a motor, right? So you can imagine like this is the moving part, in which you can control by which 1/6 the moving part moves. So you can like this. Hold on, let me just first draw the thing then. 1, 2, 3, 4, 5, 6, 7. That's wrong. 2, 3, 4, 5, 6. All right, sick.
Yeah, because a conventional motor has the electromagnets on the.
So basically, you have 3 outputs, and if you apply voltage to the blue one, then the motor is gonna move from here to here. If you apply voltage to the yellow one, the motor is gonna move from here to here. If you apply voltage to the red one, the motor is gonna move from here to here. And if you apply negative voltage, they're gonna go the other way. So basically, you want to first apply to the blue one, right? First, you want to apply voltage to the blue one, then yellow one, then red one, then blue one, then yellow one, then red one, and just keep on going in circles, because then you will first apply to blue one, so the motor is gonna move from here to here. Then you're gonna apply to the yellow one, so motor will move like this. Then red one, so the motor will move like this. The blue one, so the motor will move like this. And you just wanna keep applying voltages in this order. Yes, and that's basically what ESC is for. S- For
And the reason why it's brushless is because standard motors, the core and the actual rotor on the inside has actually the windings. So you need to have a brush go to the center piston that translates the power into the coil, and the coil itself spins. And so the brushes are there to keep contact with the electrodes on the outside, because usually, the outside of a motor doesn't spin. But a brushless, it's the opposite, where the coil stays the same, and then it's actually the magnets that spin as opposed to the coils. So then you don't need any brushes. But on the flip side, it's a little bit more complicated because you have to actually use some very smart control in order to make it spin.
and that's
Because
what
yeah, it's true
we're going to
that you
do. We're
could
gonna
apply. Yeah.
make it spin. So, okay, open. Oh, that's what you said. Oh yeah, this one. Okay. Hold
What's
on.
also interesting is that you can use one brushless motor to power another
With
if you
Arduino, in
spin
order to produce
one
these different
mechanically
levels of the
and
current, we
plug it
going to
into
use
another one, it will spin
PWM,
it with the
pulse
electricity.
width modulation. We're
But
going
this
to
shows
change
you how
the
they do the
duty
pulse width
cycle of the
modulation
pulses.
to
Like if we have the
get
pulses
from
like this, the average
PWM
level is
to
somewhere
the
here.
sinusoidal
If we
wave.
have the pulses like this with the
And
But
it's,
I don't
he
need
does a
why
really
the
good.
sinusoidal wave is necessary.
here,
That's
okay?
what I
With
understand.
the low duty cycle,
It's
the average
necessary
value is
because
somewhere
the
here,
way
like
that
this, with
the
pulse
the
width
magnets are
modulation,
spinning,
PWM,
you really
we can
need a
change
sine wave.
values
Otherwise,
of
the motor
our
is
output.
fighting itself because of the way the magnetism works inside of the motor. Because you can't just apply a voltage to one of them. It has to be a sine curve. You can make it a trapezoid, but if you send a trapezoid signal, to the motors, they're not going to be that efficient, and they're going to shake and jitter depending on what angle they're at.
Oh, okay. But this is a
Yeah,
software.
because
But this has a software fix, right?
no,
Pulse
no,
width modulation.
but pulse width modulation, like he's showing you, because yeah, you see the green, the blue, and the red on the bottom left.
Yep.
Those are mimicking, yeah,
So wait,
the
but
outputs.
that's the one thing. Is can't you do it with software?
So yeah, the software creates the PWM output,
Okay.
but if you imagine the average of the green signal at the bottom, it would be that dotted line toward the very bottom, like 0.1 volts. The average of that blue signal would be, like 5 volts, and the average of the red signal would be like what, 7 or 8, doesn't matter. So instead of actually creating a sine curve, you're just sending a pulse width modulated signal that averages out to the dot on a sine wave. I'm so horrible at explaining.
I mean,
But
this is electronics with waves. Okay, I don't think anyone would be great at explaining this because this is
but
combining
just imagine
electronics.
this. So
I mean,
so
I get the
you see
idea.
the sine curve. Yeah, yeah. So if I turn it on for 0.1 seconds and then it's off for the 0.9 seconds, the average voltage is going to be like next to zero. But if I turn it on and turn it off, 1,000 times, but it's on and off equal amount of time in that 1 second, the average would be half of whatever the voltage at the peak is. So it's pulse width modulating the voltage. It mimics the output. No, I can't explain it better.
Okay,
Nope, I'm gonna shut
give me
up.
a second. I just need my multimeter from across.
I was
Sick because right now we will be making capacitors. Of course, you need capacitors. You always need capacitors when you sick. That's a good piece of advice for anyone out there, actually. If you want to know if a circuit will be annoying to make, just check if there will be capacitors involved. I still don't know exactly how capacitors work. I mean, I know, okay, I know how they work. I just don't understand what they do. So so how they work is they just collect charge and then unleash it, right?
Yeah, that's my
but then you have these circuits in which like you use them in order to reverse the voltage from positive to negative. And apparently they're just this is just magic.
Yeah.
Honestly.
So it's like they're charged up, and then when the voltage is released, maybe negative, then capacitors also smooth out noisy signals.
Yeah, and that feature I do get too, because well, moving on, that makes sense for a capacitor, but I don't understand their magic properties. This magic is wizardry.
Well, you can make a you probably know this, but that the Styropyro made a capacitor out of 2 pieces of aluminum and a piece of plastic in between them.
Yeah,
which is kind of cool.
All right. Oh,
Yeah,
now my PC is detecting. Oh, now my PC is detecting the Raspberry, but not the. There we go. That's the camera. Sick. So what we're gonna do is we're gonna try to. We can move this. This is surprisingly heavy. It is really tiny. Doesn't look like it, but it's surprisingly heavy. Okay. We will try to reverse a signal, and that's it. So we will install 2 different diodes at the very end, which we will use in order to measure which way the signal flows. Alright, 2 diodes. Can you all see them? You can. It's very bright, but you can see. Sick. So if we set them up one way, like this, the blue one lights up. If we set them up the other way, then the white one lights up. Sick, cool. So now, what we're gonna do is we're gonna just plug in these 2 cables. There we go. And there we go. And now we've started. So what we want to do is we want to create a circuit in which after pressing this button, the signal would reverse from positive to negative. That's the kind of goal. I have crazy lot of capacitors. I have crazy lot of transistors, and I'm ready to go, I guess. So when it comes to these circuits,
Okay, I finally found an image, and sorry, the image finally I pasted in Discord that shows how they use PWM.
Oh no, I get how it works. I understand how
Okay.
modulation works.
That is so
What I
hard
wasn't
to
understand.
describe.
I mean it's I mean you just think of it as an average of voltage,
Yeah.
not the voltage itself.
That's right. Yeah.
Okay, so oh boy, I should really switch it up a bit so we have a camera like this. Oh, I'm a professional, don't worry. And then display capture of screen walk. There, wait. Oh yeah, I'm a professional. Oh yeah, perfect. And then it grows like dark rectangle in the top right corner. So, we would like to start with this circuit, I suppose. I mean, this looks like a just simplified version of this circuit. And with if we set up a button right here. Oh no, that's the plus. That's the out. Ooh. So if we set up the button with the ground, it should. I have no idea. Okay, which way do capacitors go? They're asymmetrical, which means they will only go one way. So
depends on the type of capacitor. The ones that have a negative.
No, I mean, you know, from these the notation wise. Which
yeah. I don't know the shape of a capacitor like that.
I think it's
the ones that
based on diode. I'm hoping. So there we go. To socket capacitors. Oh yeah, I need diodes. I didn't bring any diodes. Okay, hold on for 1 more second. Whoa. Ouch! That hurts.
What do they call that? Symbol? Orientation. I'm just gonna paste stuff into the Discord.
You know what I need? I need a lab. I know that's every man's dream, but I need lab. Oh, thank you so much. That's so.
Yeah,
Thank you.
I can be your helper. I'll paste like diagrams into Discord. How
Right,
about that?
that's sick. Now, I also always forget the long part, right? The long one is the plus, correct? Am I? The long end is the. I mean, I can check.
Don't. I literally have to look it up each time because
It doesn't. Yeah, it's. Let's just break the diode.
I
I
do
think I
have to
just
look it up each-
broke the diode.
Yep. Yep. Game suggestions. So I was trying to make it Far Cry 3 earlier, or Far Cry 4, because you can play co-op, and I just started playing Far Cry 4, literally 3 hours ago.
Would love to. Okay, I think these two diodes are better. Damn it! Why am I? Why am I? Hold on, I need to go get some more diodes.
At first, and also you need to put resistor.
Silly kind. I don't need the silly kind. I need the good kind, professional kind. Where are my good diodes? The solid. It's outstanding. Some of them are bad. Let's hold them go. That's
You also want resistors on the LED. But yeah, the long wire is the plus.
take this with me. Okay. Sick.
Yes, the long wire is the plus, but you also want a resistor though, depending on because that's
Do I?
one of those
I'm.
is 3.3.
I don't know if I need the resistor. I think we'll be just. I might have just bent another diode. I might need the resistor.
Yeah, because usually you use again with LEDs PWM because you're not supposed to change their intensity by just increasing the voltage. Usually you use pulse width modulation to dim them and brighten them.
All right. No.
He's I think make it's using 3.3 on one side and 5 volts on the other.
Yeah, we're
There's
gonna be
two
using.
jumpers that I can't read on his board, but I'm assuming
Yeah, we're gonna be using
the two jumpers are
3.3.
both on one side.
So
Okay.
I should use a convention for my colors, but I don't, because I'm an awful human being. So yeah, I don't use. All right. Now, one more thing. Oh, this cable is broken too. That's great. Now, let's see if I could revive this diode. Plus. Minus. Okay, the blue is the plus here because once again, conventions are for losers anyway. I am in full support of colorblind people, so yep, it's bad. Okay, I'm kind of hoping. Walk. Oh, it is glowing. It's just very dim. You can see it better on camera than me. That's festive. There we go. Sick. Now all we need to do is just set up the circuit, this one. So, oh
Nice.
goody, am I glad that I'm doing this without the, okay, so this is ground. Let's have ground right here. Now to ground, this is ground, this is our input. So right here we have our input, right here we have ground. Now, from the input, we would like to, which way? The plus way. So from the input, take the capacitor, plus way, like this. This is gonna be a sick circuit too. Definitely not the wrong. there we go, this capacitor. From it, we like two diodes going two separate ways. So, two diodes. I'll use green ones for this. One which goes plus to ground. Wait, no, minus to ground, plus to ground. Huh? One which goes, okay, so this one which goes, this is so gonna be so awful and confusing. This is gonna be awful. I can already tell. Alright, so we'll
Trying
have,
to pull up my breadboard diagram that I made. Oh, I actually have a Tinkercad is good for this. Forgot.
I'm just going two separate ways. Except one of them has an additional capacitor. Because of course, one of them has an additional capacitor.
Create one.
Shucks. Stick in. Alright. Now the capacitor will go the plus at the bottom, which means it will have to actually go backwards. Remember, kids, the best electronics are always made when you have absolutely no idea what you are doing. Wait, plus is the...
Oh, they don't have a capacitor. Yeah, they do polarized capacitor.
So plus, we go this way, there we go, and then this connect to ground, and then in between, so right here, is where we'll have our
Anode.
this one. Wait, is negative voltage really gonna? Wait, that's dumb. That's not. This isn't gonna measure negative voltage. This isn't gonna measure negative voltage at all. And there's diode. Diodes the good deal. I have no idea. I don't know what I'm doing. In case it wasn't clear. Oh, this
That's
diode. I know you saw that, but I plugged it in. Cable's falling apart. It is glowing. Very dimly. Okay. I don't think it's working. We have this wire, and then this being the ground right here.
Okay, so you have both of those going to the same one. Go to the minus.
Come on. Give me -3. That's nothing. Ah, well, shucks. Charge from second. Here capacitor C1 charges from 0 to 10. Does it
Have
though?
you ever? So what I was doing is I'm trying to recreate this on Tinkercad while you're doing it on a real breadboard
That's smart. I should have actually done it
But-
personally.
because we can actually play around with it and not have the because it emulates it.
Is it? Think it
So just
can't.
because I would burn out so many LEDs if I was doing this.
I already did, so you know.
yeah,
That's
yeah.
so. Wait, is Tinkercad in KiCad or?
Tinkercad is just a web browser.
Oh, amazing.
You just
Would
yeah, you can just log in with an email and it's free. You just create a new instead of a new 3D, just create a new circuit, and it allows you to do the breadboard thing. And it emulates the circuit on the breadboard, which I'm trying to recreate that diagram, but screenshot. There we go.
create your first circuit. Well, that's convenient. Breadboard. Alright. So, the way this is supposed to work is, let me just switch. Second. Have input voltage, and then the output voltage. And then we have there we go, then this will go right here, and then we'll have a diode. Going to ground. Yes. Alright, and to that ground we will also connect right here another capacitor, but these, oh wait, aren't these the both side capacitors? That should be wrong.
Yeah, you can actually type in capacitor in the search because that's just the basic components, and you can find a different one. You just have to in the search type in
Polarized capacitor, precisely. Why is polarized capacitor just large?
Yeah, it is bigger. I had to put it off the breadboard because it covered up the breadboard, and I wanted.
Oh, you can just connect stuff like that. So convenient.
Yeah, isn't that cool?
That is cool.
iCAD is. They do a good job.
That's amazing. Okay.
I still use KiCad for the first day of my projects.
I can see why. And then this goes right here. Hold on. This negative will go right here. And then this negative will connect to the diode, and that will be connected also to the cathode anode. Why can't they just call it positive negative? Why there's so many? It's always cathode. There was a way to remember that, but I just refuse. What's the progress update? There is an update set. Which one's the cathode? Which one's okay? Anode is positive.
Having a catheter is a negative experience.
Well, then I'll never forget that, I suppose. Okay, so
Yeah,
cathode is
cathode
negative.
is negative.
All right, so this
Having
one.
a catheter is a negative experience.
So this one is the wrong way around. It should be this way. Cathode to negative. No, it was correct. Now I'm just an idiot. There we go, and then we have this.
I'm actually following along with you too.
Which would be anode. There we go, and then the capacitor, except the other way. So this one actually hooked up to the minus, negative, and then positive going straight to. We'd actually rather do this. Ground. And then in between these two, we have an out voltage. Like this. This is our out voltage. Is there a potentiometer? No, I'd like to something that could measure the out voltage. Soil moisture sensor is a basic component. Multimeter. Festive.
And then you also have that connected over here.
0. That's because I
And
didn't
that is
connect that
connected
to
to-
nothing. And maybe I should connect like a battery there. This also would probably help.
Oh yeah, yeah. I'm almost duplicated your circuit.
0 volts. My heart is to be white and both. Girl, okay, hold on. Am I dumb or just an idiot?
And you can color those wires if you want to.
As I mentioned, standards aren't really, color standards aren't really my thing. Okay, it is 9.
Okay.
So 91 of these lights up. You know what? I'm gonna try the other circuit. Also, over here, capacitors go both ways, which is a bit nicer. Alright, let's delete all of those. Plus and minus. Oh, this is gonna be festive. Push button actually. That was a negative experience. Why is this so memorable? Well, I know why, but sick. Looks like that. I'll do it. This will be our first one, and then we'll have our second one. Imagine you have to refresh the page in order to fix bent LED mimics real life.
That'd
Alright.
be nice. Can't you Control Z when you mess up a LED?
Why is the resistor? Press R to rotate, so intuitive. In between these two, we'll have a resistor. Like this. And then, oh, this has to go back. Ah, it's always something. There we go. No, I don't know, because that should be resistor which goes left right here to ground, except from that ground it also connects to the capacitor like this. That's only one of them because there'll be also another on the other side. Will connect right here where the input output will lie. So potentiometer multimeter, I mean, to connect this to positive, negative, start simulation. Okay, this is certainly an interesting circuit.
Oh, nice. Oh,
Wait,
it's
it's
8
dropping
volts.
quicker and quicker. Is it really gonna drop into negative? Oh, never mind, slowing down.
Let's.
Now, the question is, did I screw up the circuit? Oh. Ah, there's some other problems. This one just recharges the capacitor. So does this one. That's not what I wanted. From AC mains, that's...
Well, there's no way for that to
Ooh.
go negative, right?
This looks interesting, though. Hold on. That's an interesting...
Trans-
That's an interestingly simple circuit.
Oh, yeah.
Alright, cleaning stuff up is... a bit more difficult. Alright, time consuming.
Can you? You can actually just hit the. No, never mind. No, ignore.
Okay, this is an extremely simple circuit. So I'm really hoping it's gonna work. So... resistors. And this time we can actually... Alright, so this... Going up, going to middle. You know what, why am I doing this on a breadboard, actually? I feel like it would be just easier like this.
Yeah, without the breadboard.
Yep.
The breadboard's nice if you're trying to duplicate something to make sure you didn't mess up.
No,
Bless you.
thank you. I feel like I'm coming down with something. I haven't been feeling well. I've actually also felt like off-putting today's stream again because I ain't feeling great, but at some point. Positive right here. From this point into... Well, that's my multimeter.
I hear that so many times. It's like, ah, dang it.
I know,
gotta
it's
turn it up
it's always
again.
so annoying. Because it's so dramatic, too.
Yeah.
There's no need to be this dramatic.
Batteries are not that scarce at the moment.
Yeah. Bless you. I think I was sneeze. I don't know.
It was a cough, but I appreciate
Close
the,
enough.
Ooh, this is kind of funny.
Okay, so I should connect this. Is it like, can you get like a single pin?
There are pins, yeah.
It happens. Oh, that's great. Wait, pin.
Yeah, header pins.
Header
And
pin.
from components, instead of basic, go to all. At the top, where right underneath starts. Yeah.
Oh,
Above
there we
that a little
go.
bit.
There we go. Alright, so now from these, we'd like to plug them in. And also this, and also this. There we go. And now the potentiometer or no, multimeter. Now we're doing magic. We're not really doing magic yet. Negative, negative. negative, and this to positive, and this to positive. Start simulation. It's goes to 0. Probably because it should go to. Probably because I'm an idiot. That's probably why. This should go to ground, not negative. How do you achieve ground? There is no.
This ground is in the center.
How does one achieve ground in electronics? Always ground is a reference thing.
Yes, it's relative voltage. If you have 100 volts and then 5 volts, I guess it will see the 5 volts as ground, right? It's just the voltage difference.
Okay, so ground means nothing. And why isn't this working?
Well, I think you want, yeah, so you would connect the voltage to in between the two capacitors for the voltometer or the voltometer.
Oh, because that's ground. You are so smart. Yeah, you are so. Wait. That's for negative?
Yeah.
Oh. No, wait. That.
Because you don't
that doesn't
necessarily
work.
want to connect it to ground there.
No,
You-
another
'cause-
over 0.
you see, yeah, you want to connect it to the center, yeah.
No, but now they're both 0. It didn't work. Unless pins work in some different magical way. Hold on, let me
Well,
just.
those header pins aren't connected to one another.
Then that's probably why it
those-
didn't work.
y-
Yes.
Yeah, you can connect them.
Okay, so I suppose I'm gonna connect all of these right here.
Yeah, that will.
Oh, what? Oh. Oh. Whoa! No way! No way! It actually worked. That's ground was always so confusing to me because I always thought of that component, which I guess I see where I went wrong. It actually worked. Well, you know what that means now? We can just take a button, push button precisely, and then just have. Well, that's a good question. We basically want a single. Now we want to change up the circuit a bit, but since we have everything connected to ground right here, it makes it a whole lot easier. And when I say whole lot, I do mean a whole lot. Because we could have this right here be our button. Delete this. Now we start simulation. This only works when the button is pressed. Oh, it isn't showing 0 volts, it's showing milliwatts. That's cool. And now the second thing is that. Oh, that's a good question. Because I could certainly do the 3 buttons, but no one wants 3 buttons. NPN transistors also never worked for me. I don't know if I just did it physically wrong. I'm actually gonna check right now. If I understand correctly, a diode, I suppose.
I bought a whole bunch of transistors like PNP and NPN just to try to understand them, but it's all about those thresholds, right? Because I understand the concept of transistors, but like actually using them in circuits is always different.
Oh, that's precisely what I mean, right? I mean, I've tried this
Yeah.
circuit like this so many times, and it just works in software. It just works. It makes sense. There we go.
Yeah.
It works like it should. But for some reason, in real life, I'm struggling. Right, then this will actually should be at least pretty simple, because then what I should do is I should just have a button so that if it's off, we want this to go on, and if it's on, we want the other one to go on. This one is simple enough, just plug in the button. But we want to like create a NOT gate with the other one. There's like a switch, by the way. Switch.
Well, there's always like the, single pole double throw switches. Those I use a lot, but since you're going to be using
Oh, slide switch. What's common in the slide switch? I just mean like a button which I don't have to hold. Isn't that a component like this? Why does it have 3 inputs?
Oh yeah, because because it's always connecting 2 of them, so it's either the left and middle or the right and middle, depending on which way it's toggled.
Oh, then never mind. Then this actually solves so many more of my problems.
Yeah.
Huh.
Yeah. So when it's on the right side, it's connecting the right and middle. When it's on the left side, it's connecting the left and middle.
This actually solves my exact problem. So, I mean, I'll have to find like a transistor alternative for a switch, but I'm certain those exist.
Yeah.
There we go. Circuit should be done. And like this. Start simulation. So now, there, I think we've cracked the case. I think this should be the circuit. So right here, these two would be these 2 switches would be controlled by the Raspberry Pi, right? And then if you need 0, you keep them like this. If you need positive voltage, you do this. If you need negative voltage, you do this. And there we go.
And so you have a square wave generator.
Yes, and then the pulse modulated, I can just implement that software-wise, which will be a better deal for everyone, honestly. Oh, why am I so tired? Damn, this is stressful recently. It's physically affecting.
It's funny because there's a DC motor with an encoder on it.
Wait, what?
They even have, yeah, well, as one of the components.
Encoder. Oh, that's one of the annoying ones. I have that one actually. I think.
Yeah.
No, wait, mine present has 25. Wait, is there no brushless motor?
It doesn't look like they have a brushless motor here.
Which is weird. That would be such a simple one. Isn't it an oscill? There is an oscilloscope! Fantastic news! Now all we need is just... This is super hard. I mean, it's not yet. There's just a lot of things going on. So a software switch. So a transistor switch.
So if you it's cool that they provide you the schematics. If you click on the top right where it's blue, next to it looks like a component. I didn't even know that.
There we go. Oh my goodness. Wow.
Yeah, so it even gives you this, but you can design, I think. Oh, I guess not. Yeah. It's still cool that they give you that. That's kind of cool.
This is so easy.
Bye, Sleepy.
There we go. That's actually the circuit. This right here. Wait, where's the oscilloscope? Actually, that's a good question. This is the, okay, we don't want an oscilloscope, we want Is this something like a custom component or output?
Oh, yeah, I don't know where that is at.
Because that'll be just some USB. I don't know, whatever. Good enough. Just something to mark where the output is. Ornate pin header. I have no idea. There we go. Sick.
Yeah, nice.
This is the circuit. Except one thing, one problem. Well, two problems actually. First problem, the obvious one. These won't be the actual resistors and capacitors. We'll need different resistors and different capacitors depending on the voltage required. And second problem, these cannot be switches. They need to be whatever the transistor version of a switch is. So
Yeah.
transistor switches. Using no, I mean like switches from
As
transistors.
opposed, yeah, because like a MOSFET is like an amplifier, right? And then you're just looking for like a PNP, right? PNP transistor.
What is that? PNP.
Is on when the value of the voltage source is connected to the base is low, and turned off
Oh,
when
but
it's
we
high.
need
So it's like a
four
PNP is like
inputs.
a NOT gate. Yeah.
We need four because we need input 1, input 2, output, and then the picking one. So transistor control. Yeah, power control is what I'm looking.
Hey, they have an H-bridge motor driver in the power control. The L293D.
Yeah.
That's actually what they were using in the other circuit. That's funny.
We could, I could actually do it the smart way. Who needs to do it the smart way though? When you can make it the make it way. Okay, is there really no such thing as a switch, as a digital switch?
So yeah, all transistors are that way, right? It just depends on how much voltage is applied to it.
Yeah, but
And
my
how it
issue is I
functions.
need like two inputs,
You like it like
two
yeah,
inputs,
like a gate
output,
switch.
and then something which allows me to switch between the first one and the second. I suppose I could implement this with transistors. Hold on.
Yeah.
Let's put my genius to use. So what I want is
You can do a dual comparator because they have a dual comparator here.
no, that's too complex. That's too complex. I want it to be simple. So what I want is I want something which will allow me to actually no, let's pick a resistor. There we go. We're gonna have a diode. Or actually, oh damn it can't be diode. I need something which will, oh I'm an idiot. Multimeter. That's right, there we go. Sick. We'll have a multimeter. This is 9. Okay, so amperage. And then this. Positive right here, and then positive right here, and then this right here, and then this right here, and then this right here, and then if we start the circuit, we can switch this to amperage, and we have 6 amperes, and then we switch it, we get 0. I mean, micro, whatever. There we go. That's how we switch 6, and I need to implement this, except with transistors. Well done.
6 amps. Wow, that's impressive.
That's a powerful battery. Okay, so we'll have this. Hold on. Why is this so difficult? It shouldn't be. It should be simple. I'm good. Okay, we have output, we have two inputs, we have three input, we have two inputs and a logic input. And we want this one, if it's 0 or 1, to determine these two, which means we can have a transistor right here, which this output logic, and then another transistor right here, which will be this output logic, but inverted. This is really way too complicated. I really shouldn't do it this way then. Because first of all, I need to invert the signal, and then I would need to combine them somehow. How does one combine an output? Well, just plug them in both. That's how. Plug them in both, and then there we go. How do you inverse logic input? Wait, PNP. How does a PNP transistor work? I don't.
PNP is like a NOT gate, because the a PNP is on when the value of the source is low. If it is a low in the threshold or 0.
No, but I mean, like, PNP has 3 pins.
Yeah, the emitter, base, and collector.
Yeah, and NOT gate would have 2.
Well, a NOT gate is gonna have more than 2. A NOT gate is gonna have to be connected to power, right? Because how could a NOT gate have
Oh,
power
so
come out
PNP
when
is
no
just an
power goes into
inverse
it?
of NPN.
Yeah, right. But think about it. How would a NOT gate have no electricity plugged into it but still emit electricity? Because that's what a NOT
That
gate does.
makes
If
sense.
0 is the
Okay.
input,
Oh,
the
then this
output's
is actually
1.
incredibly easy. It's just 2 transistors. That's all I need.
Yeah, so a PNP is I think, the equivalent of a NOT gate. Again, this is new territory for me too.
Okay, emit.
I do a lot more complicated things, but the simple things sometimes can be more difficult for me. Which is kind of funny.
Alright, then pin. There isn't a single pin. There are only 8 pins, which is also
Hungry.
really upsetting.
We use brute force when it's absolutely unnecessary.
Necessary.
That's true.
The
It's the
make
hacker
it way.
mentality.
The make it
The
way.
make it way.
Alright, there we go. These. And now we take this one, plug it in. It doesn't really matter where. Hold on, there we go. Wait, did I just do it? I don't. This, and then inverse, and then collector to positive, and then this to positive, and then start simulation. I screwed it up. I done goofed up. Oh no. Oh no, no, no. This is wrong. Why is this wrong now? Oh, this is such a mess too. Wait, what did I do wrong?
You know, I don't know, because I would have to study the way that these operate.
I mean, in my mind, if I just have NP and PNP, right? If I have this button off, this one's gonna be emitting. If I have this button on, this one's gonna be emitting. Which is exactly what I need.
Yes.
I'm just gonna spam potentiometers everywhere and then figure out what's going wrong.
And you also have the output in amperage as opposed to voltage.
Yeah, because voltage is the same in both. Alright. Let's see. Oh, well, that's interesting. Huh. When I'm pressing this button, the amperage right here goes up. Oh, because it's transistors. I forgot these are physical transistors. They do some weird stuff because of course they do.
Yeah.
Okay, so I need a transistor which wouldn't amplify stuff.
That's why integrated circuits are used quite frequently, because not only do you have the transistors there, but the accompanying resistors and capacitors. Because usually the switching, how fast they switch, what the threshold is for the transistor, all those things are kind of taken into account. So I usually just use integrated circuits because building from unless I'm doing some kind of power thing, then usually you kind of want the
I have a
beefier.
fixed idea. I have such a glorious fixed idea. Tef, that's gonna blow your mind.
Okay.
This is my fixed idea. And then negative. Wait, where am I gonna plug the
Potato?
negative though? Yeah, I suppose.
It's potato logic.
Oh no, potato isn't strong enough for the transistors. No, potato logic. Why have you forsaken me? We need something stronger.
Oop, I better get going though.
Yeah, I'm gonna go too soon. I'm really,
Have fun
really,
with your
really
potato
tired.
logic.
Wait, am I just going all wrong, or am I can't tell if I'm dumb or am I an idiot. Oh, the PNP requires probably more juice. Why? I don't know stuff, honestly. This is to say that it's where okay. It's yeah. I feel like I'm so close, so unbelievably close to cracking the case, and yet so far at the same time. What if I just do this? Would that be enough? No, it wouldn't. I'm so close yet so far. You know what? I'm gonna go for today. It's been an awful day for me. A really a bloody awful one. And I just I can't anymore. I can't. My PSU is screwing me over. Anyway, I suppose for now be it. I would like to thank you everyone so much for watching. And have a great day. Bye.